Hello. So let's look at the the last sutra, which is Sutra 14, Ekanyunena Purvena, and this is translation basically means one less than the previous one, right? One less than the previous one. So, this sutra provides an elegant method for division by numbers that are one less than the power of 10. It could be 10, 100, you know. Uh, so, it could be such as like 999, 999, right? So, instead of the power of 10, 100, and 1000. Okay. So this authentic Vedic mathematics, in this one, this sutra reveals the profound understanding of number relationships and computational efficiency, right? So the ancient sages understood that division by numbers like 999, 999 can be transformed from complex divisions into simple additions with carrying. This demonstrates that sophisticated understanding of number theory and computational efficiency thousands of years before modern mathematics formalized these concepts. So we look at two examples. The first one is an example of division by 9, right? So basically, we are taking 1234 divided by 9, right? So when you see 9, it's 1 less than 10, right? That's our base. Base is 10, but this is 1 less. So this triggers the use of the complement method, okay? So we kind of start with 1 and we add 1 plus 2, the second number, so that's 3, okay? And we continue on with that. Then we take that 3 and we add it with the second 3, and that's 3 plus 3 6. Then we take that and 4 and 10, right? So just remember the steps on how we add that. So what happens with the first one, right? That goes straight into the answer. So the first quotient is that 1, okay? So now what happens is, as we did the 1 plus 2, and that's a 3, right? So that becomes the second quotient. Okay, so we have 1 and 3 here. So 1 is the very first one, and then when we do the 1 plus 2, 3, that's the second quotient, right? So 1 plus 2, 3 is that. Now we continue on with 3 plus 3 is 6, and then 6 plus 4 is 10, right? So let's move on. Now, how do we get this third quotient? So after we get the first two, right? So we have this 6 plus 4, right? Which is 10. So since 10 exceeds our divisor 9, right? So we divide the 10 by 9. So it is this 10 here, right? After we add these two other numbers. So we divide that by 9, and that is, you get 10 divided by 9. What do we get? We get the quotient of 1 for that particular division and the remainder of 1, right? So that, just remember that. So that quotient 1, it will get added to our previous working value of 6, right? So here, remember 3 plus 3 is 6. So that 6 you take, and then you add that after we divide, 10 by 9, we get a quotient of 1. So you add that 6 plus 1, 7, okay? So that becomes our third quotient, okay? And once you do that, the remainder, so 7 becomes the third digit of our answer, and then the remainder 1 becomes the final remainder, right? Recap. We take the first one here. Just remember, we keep adding. So we start with 1, then 1 plus 2 is 3, then that 3 plus 3 is 6, and then that 6 plus 4 is 10. Just remember that, how you do that, okay? The first one, 1, is also a first quotient here. And then when you do 1 plus 2, 3, that's the second quotient. Now the third one is where it gets a little bit of calculations in mind, which we need to do. So when you take that 6 plus 4, 10, right? Then you divide that 10 by 9. So that leaves you a quotient of 1 and the remainder 1. So that remainder goes straight here. That quotient 1 which you have, then you add that with the 6, and that becomes 7, right? So your answer is the quotient is 137, remainder 1. So that's the solution for 1234 divided by 9. So you see how kind of in the mind you do these calculations, right? So that's our answer. 1, 2, 3, 4, right? 1234 divided by 9, that's the answer. So what did we learn from this? So the elegant approach of this sutra transforms complex divisions into simple additions with carry, right? That's what we did, simple additions with carry over. When a sum exceeds the divisor, 9 in this case, we divide that sum by the divisor, add the quotient to our previous working value. So previous to this was this, right? This is where the 10 is divided by 9 we did. So the previous one we had was 6, right? Working value, and carry the remainder. This pattern-based approach demonstrates the computational efficiency of Vedic mathematics, where complex operations are reduced to simple, right? So remember, a lot of these are today applied in many of the AI algorithms, right, to speed up, to get the efficiencies, whether it's a search-based algorithm, it's pattern recognition, right? So rather than following the traditional method of doing it, you take complex mathematical functions or operations or equations, and then you break them apart like this, right? So that makes even the computation perspective, the algorithms a lot faster. So get the second one, where a division by 99, okay? So here recognize that 99 is 1 less than 100, so that's 100 is our base, right? So this means we work with pairs of digits. How do we pair it? We pair it as, so in this case, 12,345, we pair it as 1, 23, right, and 45. We start with 1 again, same as before, right? We start with 1, and then you add this 23 in this case, that's 24. Then you take that 24, you add it 45, that's 69. Again, remember that's calculation. Same, that 1 from before, that becomes the answer 1 here, okay? So in this case, what happens is the second one, the same way we did last time. Remember, 1 plus 2 was 3, and that became second. Here, what is it? 1 plus 23 is 24. So the second and the third quotient is 24. So you got your quotient 1, 24. In this case, the last 69, it's less than your divisor, right? In previous case, it was 10, it was more, so we divided that, right? In this case, it's less. So guess what it meant? This is even more simpler. Straight away, 69, right? 69 becomes a remainder, right? We start with that. We add, like we talked about, 24. 24 is less than 99. So that becomes our quotient. 69 is less than 100, right? So that becomes our remainder, right? Straight away the answer. So you saw how quickly you could solve this. This was a bigger divisor, bigger number, and was a lot faster than the previous one. Again, it's all about recognizing the patterns, right? So 12,345 divided by 99 is 124, remainder 69. How quick it was. Same principle scales elegantly to handle larger devices like 99, 999, etc. Right? The fractal-like nature of this method allows the same fundamental approach to work across different number bases. When working with 99, we group digits in pairs because 99 is 1 less than 100. That's base 100. Similarly, for 999, we would work with groups of triplets because 999 is 1 less than 1000. Right? Take few minutes to kind of digest that. Okay? So, Ekanyunena Purvena, right, which is 1 less than the previous one, It beautifully demonstrates how Vedic mathematics transformed division by numbers like 999, 999 into simple addition process. So the Sutra reveals the ancient sages' profound understanding of number relationships and their ability to develop elegant computational shortcuts. So the basic insights we have explored reveal that this sutra is not just a computational technique, but a profound understanding of number patterns and relationship. Like I said, used extensively today in the field of AI, writing of the algorithms processing, where speed is very important. So, by recognizing that numbers 1 less than the power of 10 have special properties, so the ancient mathematicians developed methods that transform complex division into simple addition processes, demonstrating the depth and sophistication of Vedic mathematical thinking. So, this completes our journey through the 14 fundamental sutras of Vedic mathematics, each offering unique insights into an elegant patterns underlining mathematical operations. These sutras represent the holistic system of mathematical thinking that continues to offer valuable insights and efficient methods of modern computation.